everyone, today I am going to continue the vector analysis topic of the coordinate system. Today we will see here what are the types of coordinate system. So as I have mentioned here, there are three types of the coordinate system by which you can simplify your numerical which is on the basis of the vector analysis, so that it will be easy to find out the parameters, the points in the space, you may say, okay, in the free space. Now here what are the classification? The first I mentioned here, Cartesian or rectangular coordinate system. Second, cylindrical coordinate system. Third is a spherical coordinate system. But how to identify which is the cylindrical, which is the spherical, or which is the Cartesian coordinate system? By looking these parameters, we can identify easily that is, this is my so and so method. Okay, so what I mentioned here in the first case, the x, the y and the z. These are the 3 points, these are the 3 values, these are the 3 parameters which is related to the Cartesian or the rectangular. Similarly, rho, phi, z. Rho indicates the radius, phi indicates the angle, and z is my point. In this way, if radius is there, angle is there, and one of the point you can identify by looking these exact the notation. You can say that is my cylindrical. Similarly, if r, theta, phi is there, you can say this is the spherical. In many of the textbook, this is also using as a rho, theta, phi in many of the textbook, or you may say in many of the textbook they are writing as a r also here. Okay, so r indicates as the radius, simple. R indicates as a radius. So if you observe once again, see here, x, y, z are the points, whereas in the second case, one radius, one angle and one point, whereas in the third case, one radius and the 2 angles. So easily we can identify. In the first case, there is no angle, no radius. In the second case, one angle, one radius. In the third case, one radius, 2 angles. But the question is how we can write these coordinate system in the vector form. That is important. Okay. So if assume A is my vector, I am writing for the Cartesian. Okay. A is my vector. At that time, I am writing for the which one? Cartesian coordinate system. For the first case, so not only here the one. So in the vector already I have told 3 things are important. That is nothing but my what you can say x, y and z. For so here, so ax is the magnitude, ax is the direction, ay is the magnitude, ay is the direction, az is the magnitude, and az is the direction. Okay, so x we are covering here the x, the y and the z. Similarly, if you are writing for the cylindrical coordinate system, at that time how I can write? I know very well my points are a rho, a5 plus az. Now go towards the third, that is nothing but again the spherical coordinate system, and my points are ar, a theta, and the a5. Okay, so x, y, z, rho, phi, z, rho, theta, phi. Getting? Now come towards the next. How I can write? If I am going to multiply with the dot product or the cross product, in that case how I can write? Now see here. Instead of dot and cross, first we will observe one by one this equation. Same equation I am taking here. If ax plus ay plus az. In the numerical, many times they will ask you, if equation is given, you need to find out the points. If points are given, you need to calculate the equation. So, in many of the cases, if the question is find out the ax, ay, az, how it is possible? What you need to do? I know very well. This a is related to here, so I can say ax out of ax. How I can find my ax? So, ax will be equals to a dot ax. Here, see the difference. If question is just calculate the ax, so ax will be as it is. For the ax direction will come here. But we know very well what is my ax again. What is my a here? A is nothing but again ax, ay complete vector plus az. Now dot of ax. So this ax will multiply with this one. Ax will multiply with this one, ax will multiply with AZ. So that dot product is going on. Later on we will see what will be the effect of that. Okay. Now come towards the second. If you are interested to calculate the AY. So what will be the case? A will be the vector as it is, but which direction you will multiply with the AY. Similarly, same vector will continue. AX, AX, AY, AY, AZ, AZ. But multiply with AY. And the last case, that is nothing but the Z. So here will be AX, AX, AY, AY, AZ, AZ. But that will be multiplied with AZ. But what will be happen after multiplication, that you can observe with the help of the dot and you can observe with the help of the cross product. But the case here, in this case, dot product is going on. So this case and this case, if they are the same, okay, they will be the 1. If they are opposite, that term will be the 0, you may say. Okay, so we will see later on. Similarly, if you are interested to find out the arrow, I am going to continue from here. So what is my A? A is equals to arrow, arrow, rho phi theta is there, na? A phi plus AZ, AZ. Now I am interested to find out this arrow, A phi, AZ. How I can find arrow? Okay, first arrow is equals to this part. Arrow is equals to A dot of arrow. Okay, what is A? Vector A. A is nothing but arrow, arrow plus A phi plus AZ, AZ. And how you are going to multiply with the direction? Arrow. Okay, this arrow will multiply with this one, arrow, arrow, arrow dot of arrow. Then these are the opposite and these are the opposite. Opposite will be the 0, 0 and arrow, arrow will be the one you will get as the arrow. Similarly, if you are interested in the A phi, so what will happen? A is equals to A phi. A phi. So what will happen here? So I am interested A phi, na? So A will become to this side and this will be the dot. See here, this one. First A will multiply with this one, then second time this one and third time this one, likewise. So here arrow, arrow, A phi, AZ, AZ, but multiplication with the A phi. And the last Z is equals to A dot of AZ. Now come to this point again, arrow, arrow plus A phi plus AZ, AZ dot of AZ. In this way you can calculate arrow. You can substitute the value of arrow here, you can substitute the value of A phi here, you can substitute the value of AZ. We will see numerical in the next time, but you need to calculate in this way. And the last, this was the second, and the last, how you can find out the vector in the spherical coordinate system. AR, A theta, and the A phi. If you observe here, one is the radius and the two are the angles. Now pay attention, I am interested here this AR, A theta and the A phi. So my AR is equals to this A will be as it is, dot of this will go here. That is, here will not be any kind of plus or minus, keep in mind, okay. So this particular will be equals to this total vector into that particular direction, you may say. So here again AR plus A theta plus A phi. Similarly, you can find that A theta, you can find again A dot of A theta. So here will be again AR, A theta and A phi. How you are going to multiply here? So in this case, in the first case, you are multiplying with the AR. Here in this case you are